My name is Rebecca Roscoe, and this is my video presentation for the DNA damage response mutants in the S. Pombe yeast cells. This is going to be my results. This is the Table 1.2 classification and cell lengths of the S. Pombe wild type and mutants. As you can see on this table, we have the three different types of mutants, three different types of cells, and two of them are the mutants, and one of them is the wild type. At the bottom of the table, you can see the average cell lengths and the p-values of each set of data. For the wild type, we have the average length at 12.5 for the HU minus and 18.575 for the HU plus. And we have the p-value at 3.434 times 10 to the negative 14. For the wild type, the difference between the averages is 6.425, which will be the smaller out of the three sets of averages. And the p-value is a significant p-value. This p-value does reflect that the cell's G2 checkpoint is detecting DNA damage. For the A mutant, we have the averages at 15.725 for the HU minus and 29.775 for the HU plus. The difference for this mutant in the averages is 14.05. This is a much larger difference in size than the wild type. And the p-value is 9.525 times 10 to the negative 18. This p-value is also significant, and it also indicates that DNA damage is being detected at the G2 checkpoint. For the Y mutant, we have the averages at 12.95 and 23.75, and the difference between these two averages is 10.8. And although this is smaller than the first mutant, it is still much larger than the wild type mutant. The p-value is 2.565 times 10 to the negative 7. This also will indicate that DNA damage is being detected at the G2 checkpoint. This is figure 1.1, the average length in millimeters of S. Pombe type and mutants in light microscopy. This is the bar graph for the previous table that I just showed. And here you can see all three p-values. They are all significant p-values, hence why they are expressed in the graph. The first is the wild type, and this is visually showing how much smaller of a difference there is between the average cell lengths in millimeters. The second mutant is a much larger is much larger in size, but it is also a much larger difference between the two average cell lengths. And in the last mutant, you can see that although the average cell lengths are smaller than the first mutant, there is still a large difference between the two averages. The blue indicates the average cell lengths for the HU minus, and the orange represents the average cell lengths for the HU plus. This table shows the classification of mutant S. pombe under fluorescent microscopy. On the left, you can see the yeast type. You have the wild type, the R mutant, and the S mutant, both in HU minus and HU plus. For the wild type, in regards to the DNA distribution of daughter cells, they both will be equal. And for the relative GFP production compared to the HU minus, in the wild type, the HU minus is of course the reference, while the wild type HU plus will show more RAD22 GFP production. Mutant type, the wild type is not a mutant, so it is NA. For the R mutant, in HU minus, you will find the DNA distribution of daughter cells equal, while in the HU plus, you will find the DNA distribution of daughter cells unequal. In regards to the GFP production compared to HU minus, the HU minus will be the reference and the HU plus showed less GFP production. With all of these characteristics and classifications, we determined that the R mutant is a DNA repair mutant. For the S mutant, for the HU minus and the DNA distribution of daughter cells, it will be equal. And for the HU plus, it will be unequal. Those will be shown in the following pictures that will be shown after this slide. For the relative GFP production compared to the HU minus in the S mutant, the HU minus is the reference once again, and the HU plus showed less GFP production. This will also lead us to believe that the mutant type is DNA repair. Both mutants were determined as DNA repair based off of the characteristics under the fluorescent microscopy. This is our wild type cells. In the HU minus, the HU minus will be on the left, and the HU plus is on the right. You can see here that in the HU minus, the DNA distribution of the daughter cells will be pretty equal. And same thing in the HU plus for the wild type. In regards to the GFP production, in the HU minus, of course, you're not going to see a lot of GFP production because there's no cell repair necessarily happening yet. While on the HU plus side, you do see quite a bit of RAD22 GFP production. This, of course, once again, is not a mutant, so this is a pretty standard observation. This is what most wild type will look like this is the R mutant in the fluorescent microscopy pictures. The HU minus shows equal distribution of the DNA in the daughter cells, while the HU minus will show unequal distribution. In regards to the GFP production, there is much less in the HU plus side, which leads us to believe that it is a DNA repair mutant. For the S mutant, on the left for the HU minus, there is equal distribution of the DNA in the daughter cells, Pardon me, on the HU plus side, there is an unequal distribution. In regards to the GFP production, the HU minus will be the reference, while on the right side for the HU plus, you will see that there is less production. This will also lead us to believe that it is a DNA repair mutant. Both of our mutants were considered DNA repair, and thank you for taking the time to listen to the results for my experiment.